Section 4 of Chapter 6 is about electron dot structure and Lewis structures. You will need to understand electron dot structure rules or electron dot notation rules in order to correctly draw the Lewis structures. So just remember that we said in Chapter 5 that the noble gases are non-reactive. That is because they have a full octet of 8 valence electrons in their outer shell. Because of that, they're stable and able to exist independently. They are not going to give up anything to become less stable, and they don't need to accept anything because they are already stable. Every other element besides the noble gases wants to become stable, so they will have to fill their outer shells by either gaining, losing, or just sharing electrons. So we're going to represent valence electrons for each element in the electron dot notation, and then we'll use those notations to actually show how the bonds occur in our Lewis structures. So just remember the octet rule. It says the chemical compounds tend to form in such a way so that they have a full octet of 8 electrons in their outermost shell. But do recall that some electrons or some elements are very small, like helium and hydrogen, so their octet is actually only 2 valence electrons. So just a quick reminder of chemical bonding.
The outer shell of many atoms, hydrogen being an exception, holds 8 electrons. Atoms that have an outer shell containing 8 electrons are considered chemically stable. We often say they fulfill what is called the octet rule. When atoms combine to form compounds, they can give up, accept, or share electrons in order to assemble an octet of electrons in their outer shells. A covalent bond is formed when atoms share electrons in order to satisfy the octet rule. For example, a carbon atom holds 4 electrons in its outer shell, but it would be much more stable with 8. To gain the additional 4 electrons, carbon can share with other atoms, and thereby have a completed outer shell. If 1 carbon and 4 hydrogen atoms come together and share their electrons, carbon achieves an octet of electrons. Note that each hydrogen in this compound achieves 2 electrons in its outer shell. This is the stable configuration of the first electron shell. An ionic bond forms when 2 atoms are held together by the attraction between opposite charges. The reaction between sodium and chlorine atoms is an example of how an ionic bond is formed. Since sodium has only 1 electron in its third shell, it has a tendency to give up that electron. Once it does, the remaining outer shell contains 8 electrons. This loss of an electron gives sodium a slightly positive charge. Chlorine, on the other hand, tends to gain an electron, since its outer shell already has 7. When chlorine gains an electron, it becomes slightly negative. The charged sodium and chlorine atoms are called ions. Ions of opposite charge attract each other and form ionic bonds. In this case, the attraction of sodium and chlorine form a molecule called sodium chloride, or table salt.
So as I said, you're going to make sure that you draw the electron notations correctly and understand that they're either going to bond with covalent, sharing, or ionic give and take. So electron dot notation is just a brief way to show the number of valence electrons for a specific atom of element. So remember, we're only talking about the electrons in the outermost shell. You need to remember that you use the group number for that. So group 1 has 1 valence electron, any element in that group. Group 2 elements have 2 valence electrons. We skip groups 3 through 12. They have unknown right now to us. And then anything in a teen, so like group 13 has 3. So group number minus 10. Group 17 has 7. So we're going to use dots around the element symbol to represent the valence electrons. So just make sure that you have the correct element symbol. And with that, you have upper and lowercase correctly. And also make sure your dots are big enough that you can see them, and I can see them, but not so big that they're obnoxious. You cannot double up electrons on a side until each side has one electron. So every side must have one electron before you can double up. And you can have no more than 2 electrons per side. So let's try some examples. Sodium, Na, in group 1, so it has one valence electron, one dot. I'm going to place it there. You can place it on the top, the bottom, or the left. It doesn't matter. The important part is you have one dot on one side. Magnesium, 2 valence electrons. I put one on the right and one on the left. You could put one on the right, one on the top, one on the left, one on the top, whatever you want to do. You just have to have 2 electrons. I'm sorry, you should have 1 electron on one side, 1 electron on a different side. You cannot do something like this. No way. Do not do that. 1 per side until every side has 1 dot, and then you can double up. Aluminum, Al, group 13, 3 valence electrons. So 3 sides should have 1 dot. Once again, you cannot do something like this. You cannot double up until every side has 1 dot. You cannot do something like this. You can only have 2 electrons on a side when it's appropriate. All right, carbon. Everyone should look the same for this. Yours should look exactly like mine. Group 14, 4 valence electrons. 1, 2, 3, 4. Every side should have 1 dot. Now that you have every side has 1 dot, anything above group 14, you can start doubling up. But everyone's carbon should look exactly the same. That is the only option. If you have something different, you've done something wrong. Phosphorus is in group 15. I have 1 per side, and now I can double up. But you can double up on any side that you want. So you should have 3 sides with 1 dot, 1 side with 2 dots. Oxygen is in group 16, 6 valence electrons, 1 per side, and then I'm doubling up 2 sides. So once again, yours doesn't have to look exactly like mine, but you should have 2 dots on 2 sides, and then 1 dot on 2 sides for a total of 6. Fluorine is in group 17, 7 valence electrons, so 1 per side, and then I'm doubling up 3 sides. So once again, yours may look a little bit different, but you should have 3 sides with 2 dots, 1 side with 1 dot. And then lastly, a noble gas, for example, neon, group 18 has 8 valence electrons. Everyone should look exactly the same. 1 dot on every side, and then we double up on every side. Okay, so that is electron dot notation, and you're going to use this to draw Lewis structures showing bonding. So a Lewis structure is going to use dashes or lines to represent shared electrons forming a bond between 2 elements or atoms. And then you may also have unbonded electrons as dots, but those will always be in pairs. You should never have a single dot left over. If so, you've done something wrong. But you may have paired dots left over. Those are happy because they have a friend. So let's practice by drawing the Lewis structure of H2. So you have to know what element you have, how many valence electrons, and then how many of that element. So we have 2 H's. You want to make everything linear if there's 2 or 3 things. So I have an H and H. Each H has 1 dot, so put them wherever you want. I'm going to put them in a weird spot just to kind of show you how you need to think. Okay, so I have something like that. You can have whatever you want. You should have 1 electron per side. Lonely dots are going to find a friend to bond with on the other atom. So these are going to make a line, but we can't have it looking like that. Okay, so instead, when you draw your dots, you want to make sure you put them in such a location that you can easily draw a straight line. So I'm going to put them on the inside. So I have lonely dots, and they are going to make a bond. Okay, that's all you do. But you don't want to have something like this. You don't want it to look like a barbell, a dumbbell. 2 dots makes 1 line. So you can't have dots and lines. You just want to make 1 line, and now even go a step farther and actually just draw a line without any dots, like that. So this is my Lewis structure for H2. No dots left behind by themselves. My bonds have occurred between the two lonely electrons, and now I'm going to count my octet. This H has 2 electrons because one line is 2 electrons. H is the exception to the octet, so that H is happy. This H also has 2 electrons because one line is 2 electrons. They are each completely happy. Before, they only had 1 each and they were sad. But now they've bonded, they're happy. So let's try another one. F2. So I have 2 F's linear side by side. F is in group 17. So each F is going to have 7 valence electrons. So if you want to, on the side, kind of draw out what you think your dot structure is going to look like. So 1 per side, and then 5, 6, 7. So I'm going to have 3 sides with 2 dots, 1 side with 1 dot. So once again, when you're doing this, you need to understand there's going to be a bond happening between these F's. So I want to take this lonely dot and put it on the inside. And then I'll put the other pairs around it on the outer edges. And the same thing for this F, since it's the same element. Okay, so these paired ones, they're happy. Look, smiley face. They're so happy. He's smiling upside down. They're happy. They do not need to bond with anything. The only ones that need to bond are the lonely ones. If you put them in pairs to start, they stay as pairs. You cannot separate these out. You can't take this one and put it down here and then leave a lonely one up here. So make sure you're looking at the actual dot structure because you can't separate pairs. They're already happy. Okay, so I have F and F. So I have a lonely electron and a lonely electron that can come together and make a line. Now I'm going to check my octet, which is important. This F has 1, 2, 3, 4, 5, 6, and the line is 7, 8. 8 is happy. That's a magic number. Then I'm going to look at this F. 1, 2, 3, 4, 5, 6, 7, 8. They're both happy? We're good to go. Yours has to look exactly like that. Yeah, you could draw it like this. But side to side linear is better. All right, let's try a little bit more complex one. We have HCl. Remember, I's will have a top and a bottom on them if they're capital. So this is H hydrogen and Cl chlorine. H has 1 valence electron, so I'm going to put it on the inside. Chlorine is in group 17 and has 7 valence electrons. So I'm going to put a lonely one there. And then 2, 3, 4, 5, 6, 7. Once again, the pairs are already happy. You can't do anything with these pairs. You can only do something with the lone one. So here we go. Remember, I don't want to see the dots, so erase them and draw a line, or just draw a thick line. Check your octet. H has 1, 2. That's happy for H because it's small. Chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So we are good to go. Let's try an even more complex one. CH3I. So carbon always goes in the middle. If there is a carbon, it will go in the middle. So I'm going to put C here. And then I have 3 H's and 1 I. That means I have 4 things to add. Well, I also have 4 sides of carbon. So you want to put 1 atom per side, like this. You can have your I over here. You can flip-flop these. It doesn't matter as long as you have 1 side for each thing. You don't want to have something like this. Okay, this is new. And I'll show you why in a minute. So do your dots. So carbon has 4, 1 per side. Each H has 1. I'm going to put those lonely dots on the insides. You can always erase and move if you need to. And then iodine is in group 17. So 1, 2, 3, 4, 5, 6, 7. So C has 4 lonely dots, and there's also 4 lonely dots surrounding it. So we're going to make a bond here, a bond here, a bond here, and a bond there. Check our octets out. Let's start with H first. 1, 2, 1, 2, 1, 2. H is happy with 2. Let's check out iodine. 1, 2, 3, 4, 5, 6, 7, 8. Iodine is also happy. Now let's check out the carbons. Carbon has 4 lines, 2 dots each, so 1, 2, 3, 4, 5, 6, 7, 8. So everything is happy. Obviously, this is not a great final answer because it's messy. So I'm just going to redraw it. H, C, H, H, I, and then I have to put those pairs back on because they were happy together. This is your final answer. But like I said, you can have the I on the other side with it swapping the H's. You could have the I on the bottom swapping H's or on the top. It doesn't matter as long as C is in the middle. Here's why this was wrong. Okay, I'll put my dots around my I. So if I check again, I has 1, 2, 3, 4, 5, 6, 7, 8. That I's happy. But if I look at this H, it's got 2, 4. This H, 2, 4. This H, 2, 4. That cannot happen. H can only have 2 valence electrons. Also, if I put my dots back around my carbon and I check my carbon, whoops, I have 1, 2, 3, 4, 5. Well, that's not happy either. Okay, so this is why this surrounding style is better. Let's try another one. NH3. So remember, you can always pause the video, work at your own pace, and then check your answer. I highly suggest that. Okay, we don't have a carbon, but once again, the trick is the lesser element goes in the middle. So we have 1 N and 3 H's. N has the least amount, so I'm going to put N in the middle, and you can put 3 H's on whatever side you want. I'm going to go side, bottom, side. You could go side, side, top. You could go side, bottom, top, whatever you want to do. I'm going to draw my dots. H has 1 each. Put those in the center. And N is in group 15, so I have 5 dots. So I'm going to have 1 dot with 2, or I'm sorry, 1 side with 2, and 3 sides with 1. I'm thinking about the placement. I don't want to put my 1 dot up here because then I'd have to draw a diagonal line. I want them to be straight. I don't want to put this line outside because I have to be going like a loop. The bonds have to occur between the elements in straight lines. So I have a lonely dot and a lonely dot. That's a bond. A lonely dot and a lonely dot. That's a bond. And lonely, lonely. That's a bond. And these two are already paired. They're happy, upside down happy. So they're just good to go staying like that. So once again, I suggest always checking your octet. If you don't check your octet, it's silly of you not to, because you can know if you have the right answer or not. So H has 1, 2. H has 1, 2. H has 1, 2. H's are all happy. And then N has 1, 2, 3, 4, 5, 6, 7, 8. Once again, happy. If you did something like this, or like this, you would not be making them happy. First off, H has 4, you can't have that. You also have this poor lonely dot right here. You cannot have any dots by themselves. And you have a dot lonely there and a dot lonely there. And you can't just make these into a pair. You can't have something like this. Okay, there was 3 sides with 1 dot to start, 1 side with 2 dots. You can't pair them together if they weren't paired to start. That's why that is all incorrect. And this just takes practice. Okay, let's try this one, N2. So remember, you can also have not only single bonds that we've been drawing, but you can also have double and triple bonds. N has 5 dots. Whoops. So one side's going to have 2 dots. The other sides are going to have 1 dot. Every lonely dot wants a friend on the other atom. Okay. So this can form a bond, this can form a bond, and this can form a bond. But you can't leave it like that. Bonds have to be between atoms. So you're going to have to redraw it. So I'm going to take these pairs, put them back where they were because they were happy as is. I'm going to take these pairs and put them back where they were. Don't mess with them, they're happy. And then I've now made 1, 2, 3 lines. So I'm just going to move them to in between the atoms and of equal lengths. So if you gave me this on a test, I'm not saying you're wrong, it's just not as proper to write it like that. So let's check our octets. This N has 1, 2, 3, 4, 5, 6, 7, 8, because each line is 2 electrons. And then this N has 1, 2, 3, 4, 5, 6, 7, 8. So my final answer is good. Let's just keep trying some because the more you see, the better it's going to turn out for you. Let's try CO2. What did I tell you about carbon? Carbon always goes in the middle, and I have 2 oxygens left. Make it symmetrical, a mirror image. So I'm going to put 1 oxygen here, and I'm going to put 1 oxygen here. You don't want to put oxygen attached to an oxygen. You want to make it nice and surrounded and symmetrical. So if you cut this in half, it's the same on both sides. Ready for you, so it's a fresh start. Okay, carbon's in group 14, 4 dots, 1 per side. Oxygen's in group 16, so I'm going to have 2 sides with 2 dots, 2 sides with 1 dot. I'm going to do it like that. You can do it however you want. You're going to have to redraw this one anyway. So once again, happy pairs, don't touch them. Sad, sad, very sad, sad, sad. They need a friend. You have to bond to the other atom. So I can't have these bonding. You can't have this one and this one bonding to each other. You have to bond to whatever's closest to it. So this can make a bond, that can make a bond, this can make a bond, and that can make a bond. Now they're all paired up, but you can't leave it like that. So I'm going to redraw it. I'm going to put my pairs that were already pairs back where I had them. Don't forget about that when you're redrawing. Okay, and then I have my C in the middle, and I have 1, 2 lines between this one, and 1, 2 lines between this one. This is my correct final answer. How do I know? Well, 2, 4, 6, 8 for that oxygen, 2, 4, 6, 8 for that oxygen, 2, 4, 6, 8 for carbon. Okay, here's some weird things I sometimes see with this one. Sometimes people do this, okay, and they forget to put they forget to put the pairs back. If you checked it, this oxygen only has 2, 4, and this oxygen only has 2, 4. So that's wrong. You forgot the pairs on the outsides. Sometimes I see something like this. Actually, I'm going to just combine multiple things I see that are wrong. Okay, first off, when you first drew oxygen, you had 2 pairs on 2 sides and 2 lonely dots on 2 sides. You have to leave happy pair, but you can't make that happen. You can't make a pair when it wasn't that way to start. Okay, so that's wrong. Even though it has 8 in octet, it's incorrect. Also, this one and this one are very sad. You forgot about them. Okay, so you just, by pairing these up, you forgot that there should have been another dot here that could have bonded there, and there should have been another dot here that could have bonded there, and cleaning it up would have given you that. So you just got to remember the rules. Pairs have to stay as pairs. Lone dots have to bond with another lone dot on a different atom. You cannot have any lone dots left over. And you should have an octet of 8 unless it's hydrogen. Okay, let's try this one. HCN. Carbon is always in the middle. H, C, H has 1. Carbon has 4. Nitrogen has 5. The pairs are happy. We're not going to touch them. Here's a bond. Here's another easy bond. And look, lonely, lonely pair up. Lonely, lonely pair up. Redraw it nicely. Single bond between H and C. Triple bond between C and N. And I have to take these and redraw them because they were happy to start. Check your octet. H has 1, 2. It's happy. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. If you forgot these pairs, you would only have 6. And then carbon, 2, 4, 6, 8. So you have a triple bond and a single bond and a pair of electrons. All right, so that is it for section 4 of the chapter. Real quick, I just want to show you a couple other things. Let me get a whiteboard here. If I remember how to do that. Okay, real quick. Just be aware that when you're doing Lewis structures, you need to make sure you actually read the problem. So if you see something like this, you have 2 C's and 2 H's. C's go in the middle, you make them side by side, and then I have 2 H's. Well, I don't want to do something like this. Like I said, you want symmetry. So I might actually move this H over here. I'm gonna make it symmetrical. Mirror image. So if I cut this in half, I have a C and an H and a C and an H. And then you would draw your dots. Okay? If you had 6 H's here, I have 1 H, 2 H's, 3 H's, 4 H's, 5 H's, 6 H's. Cool. Okay? What if you saw something like something like this, Ci4. Well, I have 1 carbon, and then I have an iodine, an iodine, an iodine, and an iodine. I'm going to surround it. Okay? So like I said, you just have to think a little bit logically. You can always draw something, erase it, change it, redraw to fix it. But I will say, this is a tough concept, especially when you're cyber and I cannot see what you're doing as you're doing it. So please make sure any feedback I give you, you're actually looking at to help you better learn Lewis structures, because you need Lewis structures in the next part. And remember, you can always ask for help and clarification, but you have to reach out. This is not a topic that is easily answered through chat and email. It's better to actually get on, especially to Zoom, and I can pull up a whiteboard and walk you through your problem. All right, so that was chapter 6, part 4, electron dot structure, notation, and Lewis structures.